Alright, so everything out of our hands. Just going to look at our median values very quickly. So how to calculate our median with our probability density functions. What do we know about median? Yep, it's a measure of centre and it's our middle score, correct? So for a probability density function, remember what is a probability density function? What are they? They're functions that model what? Continuous probabilities. So if we've got a probability that it's continuous, where do we expect the middle value to occur? When the area under the curve is equal to 0.5. So we'd set 0.5. Gracie, can you please explain what that means?
What means, sorry?
The thing I just wrote on the board. Probability that x is less than or equal to...
0.5.
Yeah.
A.
A. And what's A represent?
A represents the average? I'm not sure, I don't know.
What's that, Kerry? The bound, correct, Kerry, the bound. So I can set it either less than or equal to A or greater than or equal to A. A represents just the middle value of our function, correct? So I can either go from my lower bound to A or A to my upper bound. Either way, it doesn't matter. So how would I choose that? I'd pick whichever bound I thought whichever side looked the easiest way to come from. We're going to go through this example here. This is a tech-free example, and we're going to look at that. So I want to determine the median of this function here. So I want to find the probability that x is greater than or equal to A. Sorry, not greater than, we'll go less than or equal to A is equal to 0.5. So my next line of working is going to be 0.5 equals the integration from 0 to A sine x over 2 dx. So what am I looking for here? I know my area. What's the unknown? The x. Not the x. A, which is my bound. So I'm chasing a bound, I need to find my bound. Because this is tech-free, I'm going to show you the tech active in a second, I have to do it out. So negative cos x on 2 plus c 0 to A is equal to. You can often represent that as a fraction if you'd like. I then expand that out. Negative cos A over 2 plus c minus negative cos 0 over 2 plus c. The plus c's cancel. We are rearranging for A. Yeah, very good. Cos of 0 is 1. So I get negative cos A on 2 plus 1 on 2 is equal to 1 on 2. Just going to convert that into a fraction. What do I do with the 1? How do I rearrange that now? I could times everything by 2, but I can see another alternative. I'm going to take a half from both sides. So I'm left with 0 equals negative cos A on 2. I multiply both sides by 0. What's 0 times 2? So what am I really saying here? I want to find out when cos is equal to. I want to know when cos is equal to 0, when the cos function is equal to 0. Where on my unit circle does cos equal 0? Where's within my domain, where's the first one? If I start at 0, now cos is my what? X or my y? X. So where's the first time my x equals 0? What's the angle? Pi on 2. So I know that A, I'm just going to draw, I'll do it over here. A is equal to pi on 2. That's my median value. Happy with that? Does that make sense?
Can you read? Yeah.
What part doesn't?
None yet, I can't get it. So what? Because it's so 0 is equal to.
So I can divide by the 0, doesn't
So
say
you just look
negative.
at the 0 and the cos.
Yep, and what I'm really doing here is saying cos negative 1, 0 equals
Yeah.
A.
Yep.
And if you put cos -1 into your calculator, you'll get pi on 2. It won't come out as pi on 2 because your calculator isn't able to do that, but it'll be like 1.6 or something, 1.56.
Bad. Isn't it?
Now I'm going to show us how to do the calculator thing. So remember when I said you can do this in run matrix or you can do this in your solver, and I prefer you do it in your solver. This is the reason why. So I want you to go to solver. Now this is important. You need to set your function up. So when we're doing our calc, I'm just going to a little box up here. I don't need to write the solver step. We need to have A is equal to 0 to x of sine x on 2. Now I need to make sure that my calculator is in the right mode in radians. Now below that, you'll have your lower and your upper, I don't care about that. You'll have A equals and x equals. What do you think you need to do to solve this problem? Set A to be 0.5. I then put the band, the dark band, over the x. I let it equal 0 to start with. And if the dark band's over the x and I hit solve, it should come up with the answer. It will take a bit of time, it needs to think. 10? Did you set your x at 0?
Yeah, it's 10.7.
Should be.
We use this.
0 and x.
Capital X.
No, just the x that you normally use.
No, so that's 10.7. Like that. And then just press solve. Are you missing something? I made this.
So if you got 10 point something, what do you need to make sure you're doing? Checking that your calculator is in? Right.
1.57.
1.57 sounds good to me.
So, yeah, you have to make it at 0.
Yeah, just be mindful. The way this works is it trials and errors. So if you set your x value at the wrong spot, it will start trialing and erroring from there. Remember with our sine functions, they're repeating. So there's going to be multiple times when that occurs. So you need to make sure that you're setting your starting point to 0, then hitting solve. Cool, once you've got the right answer, you're in a good spot. Are we good? Anyone need help with the calculator skills, put your hand up. But the moral story is, x becomes our bound. We set our area to be what we want it to be. We cover that with the black band. We hit it at a start, and then we hit solve.